All right. Hello, folks. So today we're going to mainly talk about how to create our own generic classes or generic functions or generic interfaces, similar to the ones that I showed you last time, where we could sort of use the angle brackets and put in a type, kind of like array lists or potentially some other stuff that you'll use in the future. There's not a whole lot of slides for this, so I'll sort of go through sort of a little bit, and then I'll just sort of show you some examples of how you can use some of this generic syntax. I don't expect this to take super long, so after we're done with this, then we will go and look at PA3B, since I haven't talked about that one yet. So I'm going to make a class, and it's going to be called mutable object. And it's just going to have a few methods: a constructor, a toString, a get, and a set. So it's meant just to sort of hold any object. That's why I call it here, I call it mutable object. But we're going to start with it holding a specific object. And then we'll change it into a more generic form. Now, of course, on the slides, I had sort of some of this code and show you how to use some of it. But it's certainly worth following along, because I'm going to build up to the code that I show in the slides. So we'll write a class, and I already have a main. Yeah, so I already have sort of a main ready to go. So and it's just empty, and this is where we'll do some of the testing for it. So let's create a new class, and I'm going to call this mutable object. And we're going to just throw in, say, a specific type. Say I want this to be a double. So I'm going to create a class that basically just holds a double and can sort of do everything that that sort of a double does. So let's say that we'll make this private. We create this double, and I'm just going to call it value. So that's going to be the value of this object. And in our constructor, so our mutable object constructor, I'm going to have the user send in a double that we're going to set in this constructor. So fthis.value equals value. So we're going to bring in the value and set my data variable for the object to be that value. So easy enough. We have a easy constructor. Let's write a toString. So a toString, this is an override from object. So it has to have the exact same signature as the one from object. And we're just going to return, say, string.format. And let's have it just do percent, say, 0.3f. So we're printing a double. So let's just have it print out something related to a double. And maybe I'll put a new line in here as well. So then we'll have value. So toString, very simple. And then let's write a getter and a setter. So we'll have a public get, and I'm just going to call it get, public double get. So all we'll do here is return value. And we'll have a public void set, and this will take in a double that I'm going to call value. And we'll set this dot value to whatever came in. And that's it. That's my mutable object class. Now, it only works for doubles. Clearly, if I try to put something else in here, like a string or a scanner or whatever else I want to, if I try to send in a scanner into this, it's not going to work. But from the sort of main perspective, I can create a mutable object. I'm just going to call it MO. This is going to be a new mutable object. And I'll send in a value of, say, 10.2, but whatever. And we'll do a print from that. So we'll print out as a string. And we don't need the new line because we had a new line in our toString. And I'll print out MO. So this should print out our 10.2 with sort of 3 decimal places here that we asked for. And if we want to change the value, so that's why this is a mutable object, because we can change what it is, I can do something like mo.set, and I can change this to, say, 15.5 or 15.6. And then I could print it out again. So we have ways to change the value, to get the value, to create the mutable object. It's really my own version of a double. That's really what this is. But you know, seeing as there's already doubles that exist, obviously this is not that useful for that case. But it's not useful for anything else either. And one of the sort of tenets of sort of object-oriented programming and a lot of modern languages is that you should be able to reuse code. You should be able to reuse code. And this isn't very reusable. If I wanted to create another mutable object type of class, I would have to create a brand new one that has a different type. Let's say I wanted a mutable object, but it was used for strings. Okay, great, but I'd have to make a new class for that. And for every single type I wanted to use, for ints and for booleans and for any other types that I wanted, I would have to create a brand new mutable object class and name it something different. So that's where generics come in. We've messed around with array lists. Array lists can be whatever type you want. You put it in between the angle brackets. So that's what we're going to do with our mutable object class. We're going to turn it into a generic class. And it's relatively easy to do, but there are some things that you have to think about. So up here in the signature of the class, we have public class mutable object. I'm going to put an open and a close angle bracket. And in here, I'm going to put just one letter. Typically, it's a capital letter. There's sort of other conventions for this, but typically it's a capital letter. And I'm going to use T. Now, notice that there's no errors here. This is completely valid syntax. This allows the user, so the user of this class, so in principle, we're going to mess around with it in main. This allows the user of this class to specify what T is. T could be a double, or it could be a string, or a scanner, or a card, any type I want. Now in the rest of my code, the rest of this class, I replace whatever I want to be generic with T. So anywhere I have double, I'm going to change this to T. I'll put T here, put T here, put T here, and T here. So the user puts in what they want, and it sort of fills in all of these places where there's a T. Now, that seems very easy, and it is. This is very powerful. But toString is a little messed up because toString, I'm assuming it's a double by doing this. So typically, if you have a toString that you need to do this with, you should try to make the toString as generic as possible. And that's not always easy. In this case, I'm going to go back to sort of my regular thing of sort of creating a string and returning that string. Now, instead of giving my string a value like this, I'm going to give it a value null. So it's just an empty string. So if my value up here, if my value is not equal to null. So in other words, if there's something in here, if I have some value, then my string is going to be whatever my value is dot toString. So I'm going to use the toString of whatever this value is as my string. If there's something in it. If there's not something in it, then we're just going to leave it as null, and that's what gets returned. So essentially here, we return the toString of value. If value is null, just return null instead. So you do have to think about some of these other operations that you might be doing because they might need a little bit more care. But we've now made a generic class. This can be anything. Instead of just holding a double, we can hold anything we want. So as an example, let's go back to main, and I'm going to get rid of what I have here. Notice we have, sort of squint a little bit, you'll notice we have some warnings here. It says mutable object is a raw type. You should use that bracket T thing instead. So let's do that. Let's put in, let's say string. Then over here with our new mutable object, let's put string in here as well. And then let's actually put a string in. We'll say hello. So now if I do a print, print as a string, and we'll print, actually I think we do want a new line here. We'll print mo. And I run that and I get hello. And then I can still do all those same operations. I could say mo.set and I could give it another value. This is a string value because my mo is a string. It contains a string. So I could say world. And then I could do another print again. So I've just created a generic object. And I could create another one as well. So we could have a mutable object. If you want to put a basic type in here, one of the primitive types, you don't just put in double like this. That's actually not going to work. We need to use a class. It has to be a class name that's in here, like string or like card or scanner, that sort of thing. So there is all of those in Java for these primitive types. It's just capital D. So we could say maybe this is DMO. This is our double mutable object. And this is a new mutable object. And I'm going to show you something that you can do. You don't actually have to put the angle bracket. You don't actually have to fill in the angle brackets. This should be new here. You don't actually have to fill in the angle brackets for the second one, for the new one. You don't have to fill these in because it already knows what it's going to be from here. It knows this is going to be a double, so that will work. So you can put them in if you want to, but you don't have to put you have to put the angle brackets, but you don't have to put the class in there. You don't have to put the type when you do it. And then I could do the same thing that I did before. Print out that mutable object, maybe change the value here. This is for the DMO. Change the value to say 12.9 or whatever. And they will both work. So that's the power of these generics. If you have a class that you might want to use with different types, then you can do that with generics. And it's very easy to do by just adding angle brackets and a type and making sure that that type is wherever you need it in the code that you wrote. Now, really, that's pretty much all there is to generics. But there's a few sort of other cases that I want to talk about as well. So you can do this with interfaces, as you might imagine. So we could create an interface, and I'm just going to call this one, I don't know, pair. And usually, okay. So I just have my empty file. So let's, if you create your interface pair, you'll get the public interface pair. You get something like this. Now remember, for our interface, we just need to put certain functions in here. So when they're just the function signatures. Now you can have generic interfaces as well. I can create the angle brackets here, and I could put in something like again, we need a capital letter. I'm going to talk about exactly what the letters mean or what they usually stand for, but really it can be whatever letters you want. I'm going to use K and V. So this is two of them. So you can have as many of these generics as you want. So maybe my interface has a method called getKey. That's going to return a K. And getValue is going to return a V. And again, this can be anything. This can be anything that the user chooses. Now, this is an interface, so we would need a class that implements this interface. So let me show you that. So we're going to make another new class. And I'm going to call this one like, I'll call it ordered pair. And typically you would say ordered pair implements pair. But the pair needs values here. And we sort of pass them along. So I have K and V. That's what my normal sort of ordered pair or my normal pair uses. But when I create an ordered pair, I can also put in a K and a V, and it sort of passes them along here. It's going to take this K and use that where the K is here. And it's going to take whatever you put for V and use it for the V that's here. So if I add my unimplemented methods, immediately I get the overridden correct versions of get value and get key that started with my interface. So if I create an ordered pair object and I just choose K and V, then the pair is going to be sort of created and correct as well. Because when in main, if I create a ordered pair object, I'm going to say ordered pair, and I'm going to put in something like, say, an integer and a string. And this will be, I'll call it OP. This is going to be a new ordered pair. This. So when I do this, K will be an integer, V will be a string. And so if I look in my code here, K will be an integer. So K comes in as an integer, V comes in as a string. So for my pair interface, K is integer, V is string. So we have integer, string. That's what it sort of gets replaced with later on. Now, of course, you'd add more to this class, but I wanted to show you that, yes, you can use more than one. And you just start with it right after your whatever your class is. That's where you start with it. And then if you implement something that's also generic, you can just pass those along. Just like I put the K here and the V here. You can just pass these right along to whatever your interface is. So if you have code that you think you could make generic, then this is a very easy thing to do. So on the slides, I have a few. Let's see. So I have a few of those examples. So here's that mutable object. This one has a couple of constructors, and then there's a couple of sort of usage things here for integer and for strings. So you can certainly take a look at that. Here's that pair interface and that ordered pair. I didn't fully fill out the sort of ordered pair piece, but basically it's the same thing. We got a couple of values, we have a constructor, and then we have those overrides from the interface. And then there's some usage of that ordered pair. So the idea here is that you can create these classes or these interfaces that can be used in many, many situations. So here is the parameter sort of naming conventions. This isn't strict. You can use whatever letter you want. But typically, if you see a letter like T, that typically means type. So oftentimes you will just see T. If there's only one generic, you're either going to see usually T or maybe E for element, if it's sort of meaning an array or something, or if you're dealing with an array. K is usually key because that usually goes along with sort of a key value pair. That's why our pair was K and V. N might mean something like number. And then if you have more types, you would use like T, S, U, V, and so on. Again, these are just conventions. So depending on the language you use and the place you end up, say, working, if you're messing around with generics, they might have conventions that they want you to use, but these are fairly standard conventions. Classes and interfaces are not the only place that you can use generics. We can also make generic methods as well. Let me go back over here. We're going to go back to our main class. And I'm just going to leave this as is here. We'll mess with it a little bit later. But let's create a method. And I think I'm going to write the method first, and then I'll show you how we can turn it into, say, something generic. So because we're in the main class that contains the main method, I am going to make this public static. And let's make it public static void, and let's just have it do a print. So it's going to do a print, and it's going to print out all the elements inside of a string array that I'm going to call list or something. So this is meant to print out something from a string array. And of course, if we're dealing with sort of a string array, then place we're probably going to have a loop, and we'll take I equals 0, I less than list dot length, I plus plus, and then we'll do a print. This will be pretty easy. We'll print out a %s and a space, and then we'll print out the ith element of list. And I guess at the end of all this, at the end of the loop, we're going to do a new line. This. That way we just sort of get the last new line because we're only doing spaces between the words in here. So this is very simple. This is something we could do, partway through sort of CS1. You got an array, a string array. You're looping through each element in the string array and printing it out along with a space and then a new line at the end. So let me get rid of the stuff up here. And let me create a string array. String array, I'm just going to call this A. And let's fill it with some values. So we say something like hello and world. Let's see. And we'll go for a few. We think of the blackjack game. We could think about printing out some cards or some of the shorthands for the cards, whatever we want. And of course, we could call print and send in that string array. Of course, we return void, so we don't have to catch any values back here. And we can print, and there we go. So not sort of anything unexpected here. But let's say we want this to be generic. Right now, it can only print a string array. But what if I have an array of numbers? What if I have an integer array or a double array? Let's do an integer array. But I'm going to make it with the class instead of the int, because you can, of course, make an integer array like this. So integer array, I'm going to call it like IA or something. We could do that, but I'm going to use the object. So integer array, I'm going to call IA. And we'll fill it with a few values. We'll say 1, 2, 3, 4, 5, something like this. If I try to send my integer array in here, of course, it's not going to work because this requires a string array. That's where we can make a generic function. So to do this, so just like the classes, we need to add some angle brackets somewhere in this signature. And we're going to do it right before the void. So right before we say void, I'm going to put the angle brackets. And I'm going to put, we could put T. I'm going to use E just so you it works the same way. It doesn't matter what letter you put in here. So I'm going to put E in here. So anywhere where I define a type, I want to replace that type with E. So right here for string, I'm going to put E. That's the type. This was a string. This was a print that meant to print strings. So if I wanted to print E's, whatever this E is, then I need to put E here. The rest of it happens to be the same. The rest of it will work fine. Now, when I call this method, there's sort of other stuff that I might need to do. So I'm going to try running this right now. And notice it does print the strings. Let's send in IA. It also prints the numbers. So Java can infer what's happening. Java can infer what's happening here. Whatever you have coming in, that is what the type becomes E. So you don't have to do anything special most of the time. However, you can. If you put angle brackets before the name of the function, you can put in a type. But, and then if we look at the, let's see, we should be able to see the error here. It says, okay. So it says, looking at super stuff, constructor call must be the first statement of the constructor. So this is assuming it's some sort of weird constructor thing. Now, because we made a static function, if we wanted to define what that E was, we would have to call it in the constructor way, and then this would need to be A. We need to call it in sort of the static way. So this is just another way to call it where you can specifically put in what the string is. Because if I don't put in the main here, which is of course the class name, then it's gonna have a problem. It's gonna think this is something else when it's actually not. So this is a way that we can call it where we can explicitly put in a string, but we can only do this type of call because this is static, and I can use the class name to actually call the function. But again, if I don't put any of this in, Java figures out what this A is. This A is a string. That's the thing I'm sending in. So this must be a string. So that's what we're going to use it as. So Java, for the most part, can figure it out. But you can make generic functions as well. So if you find a situation in the future where you might want to create a function that can be used in used with lots of different types, throw something like this in. It's very easy to do. You usually don't have to change much. We literally just added the angle brackets and an E, so 3 characters, and we changed string to E, and that was it. And now we have a generic function that can literally print anything, any array. So that's this idea of generics. You use it with classes, you can use it with interfaces, and you can use it with functions. And so here's an example of that where it's sort of got a few of these things, and then I show you a little bit about how you can use it for sort of usage-wise. All right. So there are these sort of bounded types, and the code I'm going to show you, I'm not going to code it up, but I want to point out a few things. You can actually restrict what that generic can be. So you might have something like this. So this first one here, T extends and then some class name. Or T extends some class name and an interface and another interface. That would mean that the type you put in here must be a class, whatever this class is. So for example, if this class was number, then the type I put in here must be a number. That's the idea of this bounded types. So the extends keyword, it works for both subclasses and interfaces. If you put multiple of these, like the second line here, the first one in the list must be the class, and then you can put as many interfaces as you want. So let me show you this here, and I'm going to grab my pen. This is kind of like the ordered pair that I showed you earlier. This is a numeric pair. And so we have that K and the V that we talked about earlier, but this time we have this extends number. So if I tried to put a string here, it's not going to work because a string does not extend number. This would need to be an integer or a double or a float. That's what I mean by the bounded parameters. You can restrict what K can be so that you can do certain things with it. So that's something to keep in mind. These both must be numbers for this to work properly. So it's not something that you're going to potentially use a lot for the class, but it's something that you might see in certain situations. And of course, if you find a situation where that's where you want to make a generic class or some sort of generic function, this is something that you can put in. But I wanted to at least show you that you can have this extends thing in there as well, because it allows you to bound what, in this case, K and V can actually be. All right, so there's not a lot of slides. That was basically it. I wanted to show you how you could do these things with the generics, since we talked about them last time. In the next lecture, there will be event-driven programming, and we're also going to talk about the final project. So make sure to pay attention to that part. The last thing I wanted to do today was talk about PA3C. So this is very similar to Part B. So this is another class that represents a two-dimensional point, an XY pair. And what you're going to sort of do is be able to compute the distance between 2 points. That's really what's happening here. There's not a lot of code to this one. You actually don't have to write a lot. Most of that's because main is almost all done for you. So let me show you the starter code. So let's go back actually to PA3C. I do have an error message for you, so you'll want to mess around with that. And then main's almost done. In fact, you're not going to touch anything below here. So you're not going to touch this. This is just a sort of a starter thing. You can delete this. You don't need this one here. This is so main actually works if you don't play with it. So replace this stuff here with whatever you want, which is going to include a way to check to make sure that there's two numbers. Again, this is command line arguments, so you're going to use args, just like you do in A and B. It needs to take in two numbers, so if the user types in no numbers or one number or three numbers, just you want to give them a message to say, please supply two numbers. And then replace this stuff. but don't touch anything down here. So this is all the prints and the function calls and everything. So you don't have to do much here other than create the point from the X and Y value that were entered and also do that check. So main, you don't have to write a lot of code for. It's the class that you have to think about. So there's two constructors, very similar to the linear equation, so to part B. Remember that you need to put your data values here, specifically X and Y. You need to have values for that. It's because there is no, I didn't put the class data in there for you. Make sure that this constructor sets those values with the two that come in. And this constructor, the second constructor, you need to do in one line. And it must be a call to this constructor. You're going to call your one line, so this says must be a single call to the constructor above. And it initializes to 0, 0. That's the two pieces. This is going to be one line that sets the point to 0, 0. That's it. So that's all this constructor does. Then just like sort of other classes we've written, you're going to have a get X and a get Y. Those are just one line. Just return X, return Y, or whatever you call the variables. You're gonna have a toString where you're gonna make sure that it uses this format. So parenthesis, whatever the value of X is, comma, whatever the value of the Y is, close parenthesis. So make sure that your string function, it returns that, your toString function. And then probably the hardest part here is these last two. That may be the hardest part to sort of understand. So this is the distance between 2 points. So you take in 2 points, P1 and P2. How do you compute the distance? Well, that's something that you'll potentially have to look up. I mentioned in the PDF that you'll be computing the, let's see, there we go. You're going to compute the Euclidean, or also known as L2, distance between the 2 points. And I have a link down here for what the Euclidean distance is. So in the first function, here, you're going to do the math in this one. So whatever math you find to compute the Euclidean distance, that's what you're going to use. Remember that you have 2 points. So you're going to use those 2 points. You're going to have P1 dot get X. And you're going to have P2 dot get X. And P1 dot get Y. And P2 dot get Y. So just think of it as 2 separate points where you're going to be grabbing their different values and using those to do the calculation, whatever that may be. It has to do with Pythagorean theorem stuff for the math. So you're going to do the math in this one. The second one down here, it sort of looks like you only have 1 point. This needs to be a single call to the method above. This is going to be one line that calls this method. Like I said, it looks like you only have one function. Notice the difference between these two. This one is static. This one is instance. It doesn't have static, which means, let's say in my main I create a point 2D that I call P1. And that equals a new point 2D and so on. And I create a second one, point 2D, P2, and that equals a new point 2D and so on. If I use this function, I'm going to call it like this. I'm going to say P1 dot distance, P2. So P2 in this example is P. I want you to think about what is P1. How would I refer to P1 in this function? I actually just said it. So I want you to think about that. So those two are probably the hardest thing. You do the math in the first function. You're going to do one line with a call to the static version in the second function. So this one is definitely sort of amount of code wise, probably the least of any of the ones that you have to do. But make sure that you sort of follow the directions with sort of with the constructor being the second constructor here being a single call to the constructor that's above, and so on. After that, you should be able to test it because all of this printing and stuff, this is all done for you. So in main, back to main real quick. In main, the only stuff that you're going to mess with is going to be here. Again, check that you're getting 2 numbers in, and then create a point with those 2 numbers. In this case, you're going to want to use P. So have it be, point 2D P equals new point 2D, and throw the numbers in, whatever numbers you get from the user. So think back to what you did on A and B if you've already completed one or both of those. This one, sort of the main on this one, shouldn't be too bad. It's just a matter of messing around with the point 2D class. So that's all that I want to talk about. We can certainly talk a little bit more about these if you want me to, but hopefully this one makes sense with that explanation. But you can certainly let me know if you need any extra with it. All right, so that's all that I have for now. So the next lecture will be on event-driven programming. So that's where we're going to take some of that interface stuff that we learned, and we're going to apply that to our JavaFX GUI. So we can actually, click buttons and change things and move stuff around with our keyboard and that sort of stuff. So that is where we're headed coming up.